Okay, so good break. Okay, good break. You got around 30 minutes of break. Okay, okay. So we will see here like how to develop subplots. Okay, so I hope you remember the four data sets distribution of Anscombe quartet, right? Dataset one on the top leftmost, dataset two on the right most, and dataset three, dataset four on the bottom left and right. Okay, so how to make those four figures subplots? Okay, so to do that, you can see these line of codes. Okay, so now that you know about AXES and AXIS, okay, so, oh yeah. So now that you know about it, okay, okay. So first of all, we'll create a figure. So when you do plt.figure, you are telling that just create a figure template. And inside that, later you will decide whether to put one figure or multiple figures. Okay. So first of all, you have to create a figure. That is fig equals to plt.figure. So it makes a new like figure window, like, but it will be blank. So it will be on your authority what you want to put it inside. Okay, whether you want to put one plot or whether you want to put two subplots. Okay, all will be, or you want to put four subplots or six subplots, all will be under your control. Okay, so here we will see two rows and two columns how you will put in your figure template here NT. Okay, fine. So you are telling the figure like below, we will tell the figure how many subplots should be laid out. For example, we will tell them like two rows of plots and each row will be having two plots. So how many plots totally it has? It has four. Each row has two plots. So two rows will have around four plots. Okay, fine. So you can see fig dot add subplot, add underscore subplot 2 comma 2 comma 1. That means you are seeing two rows and two columns, and this is the first subplot. This first is nothing but the leftmost subplot, left topmost subplot. Okay, so that I am saying as axis 1. So you know what is AX, AXES. It's just nothing but a subplot. Okay. However, AXIS lies inside AXES. I told you that. I hope you remember that, right? AXES lies in, sorry, AXIS lies inside AXES. Okay. How many such AXIS lies inside AXES? Two. They are X and Y. Okay. Fine. So you can see that it stores the subplots axis object. So you can plot on it with, yeah, after that you can plot it like AXES1 dot plot. You can do a scatter plot, you can do a histogram, whatever you like. Okay. Similarly, this is for the first data set. Similarly, you have to create three more axes, right? Three more subplots. So therefore, I am creating axis 2, where 2 comma 2 comma 2, right? It is the top rightmost subplot, right? What is 2 comma 2 comma 3? It is the bottom leftmost plot. Okay. 2 comma 2 comma 4, bottom rightmost. Fine. So AXES1, AXES2, AXES3 and 4, right? Fine. And I am showing plt.show to show the figure, else it will not plot. Else it will not plot if you not type. That last statement is mandatory. Okay. So you can see it created all these empty subplots. Now what you should do, now to these axis objects, AXES objects, you have to plot your dataset 1 distribution, right? In your second subplot, you have to plot the dataset 2 distribution, right? Similarly, fourth dataset also, right? That we'll be doing next. And of course, you can see there is no X and Y label. There is no title also. Nothing is there. You have to type it. You have to type it. It's totally under your control. So as you can see already written here, all we have done above is to create a figure and split it into 2x2 grid where plots can be placed. Okay. Since no plots were inserted or created, nothing is showing up, right? So we use the dot plot method for each axis to create our plot. Okay. So now you remember about dataset 1, each subplot, each subset of your dataset. Dataset 1, that is the first dataset it stores. It's a subset. Similarly, you can create dataset 2, which stores only the first 10 elements of dataset 2, right? Similarly, dataset 3, dataset 4, right? So this is what I am doing here. This all things I typed again. It is not necessary. It is not necessary because I already typed all this above in the code, right? Anyway, so you should see from here. You should see from here this line. Okay. So try to see axis one dot plot. Axis one dot plot means in this plot what I want to plot. Okay, in this topmost left subplot, what I want to plot. So you can see dataset 1x and dataset 1y, and the marker is O. So it won't connect them by lines, right? So this is the idea. So you can see how dataset 1 is being plotted on the top leftmost. Similarly, you can plot axis 2 dot plot dataset 2, x comma y, and it is plotting the second dataset, right? Now, for example, you can see 3 and 4. They are all plotted here, okay? Now, for example, it is something like axis 1 dot plot, but you have used dataset 2 on the first line. Then this plot will appear here on this, right? So it depends what you want to plot. It depends which subplot what you want to plot. Okay, maybe dataset fourth also you can print first. This is dataset 1, right? Can you print dataset 4 here? So what change you have to do? Just make this change. In place of 1, just replace the 4. In place of 1, just replace the 4, and it will give you two repeating similar datasets. I mean, just an example that it is not mandatory that only 1, 2, 3, 4 the way it is. You can plot however you like. Okay, you have the freedom over there. Okay, so dot plot. No, after you can add. Before also you can add. I mean, here also we could have added them. Here also we could have added them even though there are no data inside. Okay, there are no data points inside. Even though that time also you can add the axis labels and the title of the plot. Okay, but usually it is better to add it after because you know which data set it is. Maybe you want to write on the first subplot as not x rather than x1, or this is y1 because it's the first data set, right? First data set, right? It depends. Usually it's a good practice to change the axis label after doing the plot. Good practice. I mean, before that also you can do, but it's a good practice. Okay. So remember I told you about the tips data set. Okay, tips in a restaurant, like it's how many people are giving you the tips. Okay, so you can see it's like a predefined data set in your Seaborn. Okay, so I am using SNS. I had already defined imported Seaborn library, import Seaborn as SNS. Okay, and that I am using it here. So SNS dot load dataset tips. Okay, tips. Okay. So what it does, it loads the tips dataset, which is a classic dataset about restaurants, bills, and tips. Okay. So this tips is nothing but a pandas data frame. Okay, data frame. So you can see the tips here. So it has this total bill, 16.99. And what is the tip they are giving? You can see $1.101 tip for a total bill of $16.99. Okay. And who is the person over there? She is a female. Is female, and she is not a smoker. Which time of the day? It is Sunday, and in the dinner time, and there were 2 people. Okay, that's the data set of tips. Okay, and you can also see it's a male, and for $10 he has given the tips as 1.66, non-smoker, Sunday, on a dinner with 3 people. Okay, so yeah, that's the idea. So you can see that even for $24, people are giving 3.61 tip, even with the size of 4 people. Okay. So therefore, with the number of people size increasing, your value will increase. And if your value increases, the tip, we hope it can increase. I mean, with the people, right? So that's the idea. Okay. So our idea is to visualize this data set in many ways as we can. And this will be our go-to data set, okay, for many different plots to come. Okay. So univariate, we already termed that in statistics jargon. Univariate refers to a single variable. And this we saw how to draw a histogram. So we wanted to see the total bill column. We want to assess this total bill column only. This total bill column, we want to assess the frequency. I mean, what is the highest what is the highest bill amount or tip amount. Okay, so how to do that? Is it visible to the last? Visible. Okay, so again I am creating 1 comma 1 comma 1. It's a subplot of one figure only. Okay, so you can see x is 1 dot hist. Okay, dot hist command and tips the total bill. That's the data set I want to, that's the column I want to concentrate on. That's the variable, univariate, one variable. Okay, and how I have divided into 10 bins. I have divided into 10 bins, 10 continuous bins. Remember, histogram means 10 continuous bins. There will be no, why it is continuous? Because there is no gaps in between the bins. Okay, if you have, suppose, if you have gaps in between the bins, that means you are leaving out some amount, right? You're leaving out some amount. So that is not good, okay, for your analysis. So here I'm giving the bin 10 and I'm giving the sky blue. I suggest here you try to change this color and see. You can try to change sky blue, so it is looking sky blue. You can do orange, any other color you like. Orange, it will give you orange color right now. And the edge color of the plot also. You can see these are the edge colors. These are the edge colors of the histogram. Okay, and that also you can change. You can put it white also. Many people don't like this black border, so they want white. So you can put white also. You can put orange also. Whichever you feel it will be interesting, you can use it. And this is how after the plot I have used it, but of course you can use it before also. So this bins equal to 10 divides the data range into 10 intervals, 10 continuous intervals. Of course, you can change the bar color. And yeah, anyway, these are self-explanatory. So title also we are adding. You see histogram of total bill, set X label, total bill, and this is the frequency. I think, yes, so I think our interpretation was a bit wrong in the start of the class. So the interpretation was x-axis is the total bill, whereas y-axis is the frequency. So yeah, it was, I mean, not $60. It was 60 number of people who gave that amount. Okay. So if you see that plot again, so you can see the x-axis represents the total bill. So this is the problem. When I showed you the histogram plot, why we ran into the confusion is mainly because the axis labels were not specified. So you don't know whether y-axis is what, x-axis is what. So therefore, this outlines the importance of your axis labels, right? So you can see the x-axis label is the price in dollars. So of course, the highest amount is still 50. Highest amount of your tip is still $50. Okay, but you can see one more thing, that intermediate amount of the tip has lot of frequency. That means people of around maybe 15 have given highest. The $15 tip is highest in frequency. Yes, is it? Sorry, 15 dollars is the total bill, and how many persons are there with the total bill? Okay, with $15. So you can see the persons with $15 bill total has highest frequency. That means around 68 or 69 persons have given the total, has eaten for a bill of around $15. Okay, and how many people ate for ate a lot and had a huge bill? You can see very less people. That is the towards the right part of the plot. Okay, towards the right part of the plot, you can see people with $50 total bill is the least. I mean, hardly less than 5 people or something they might have had this. Okay, so you can see this distribution over here. Okay, fine. Okay, so now what I want to do is I want to plot a relationship. I want to understand, is there a relationship between total bill and the tip they give? Total amount of bill they pay and the how it affects the tip they give. Okay, if they eat for some $70 or $60, do they give less tip? Or if they eat for $1 or $5, do they give higher tip? Is there a relationship between that? So how to know whether there is a relationship? So when you have two variables and you want to understand uh, how they are related to each other, one best plot to go through is the scatter plot. Okay, one best plot to go through is the scatter plot, because you can plot two variables at once. Okay, two variables, the variation between the relationship between two variables at once. Okay, so this is bivariate. This is bivariate distribution, like bivariate plotting. because you are taking two variables into consideration, right? So you can see this is the plot over here, but before that we'll see here, you can do the scatter plot, okay? So again, plt.figure, and that empty figure, this is the figure object that is empty. Here in this line it is empty, okay? Here it is this line, it is still empty. You are telling dot add subplot again 1 comma 1 comma 1, fine. X is 1 dot scatter. So remember, in histogram you used dot hist. So in scatter you are using dot scatter. Okay. So dot scatter, and what you are telling, this is the total bill on the x-axis and tip on the y-axis. Okay. So the tips, this is the data set, and I am extracting those columns. I am extracting those columns as x comma y. Okay. Fine. And yes. Okay, fine. And then I'm setting x and y labels and title and plt.show. You can see this. This is the total bill. This is the total bill and the tip, right? The give. You can see that most of these are clustered around here, right? Most of them are clustered around here. But that is a bit difficult to interpret. These things can give the idea from, you can get the idea from the histogram. The frequency, the clusterness, this idea you can have from histogram, because they give how many values or more can occur for a particular given total bill. Okay, but here you can see the distribution, right? For say, uh, yeah, maybe you can see most of the it is mostly stuck in intermediate cases. Like people with intermediate total bill are giving intermediate tips. Okay, like you can see 20 to 30 or 10 to 20, it is highly clustered, and they are giving tips most likely in between $2 to $4, $2 to $4 as tip. However, there are the number of points decreases as your tip amount exceeds 30. The tip amount, when it exceeds 30, the number of points you can see are less. The count is less. Okay. So you can see because why it is less? Because the total bill is getting more. So many people prefer not to take that because of economy, right? So you can see, yeah. So 40, some people, some extraordinary people, right? So they are eating for $50 and giving a tip of more than $10. Yes, this one. Which side? This. Which point? Left top here. Okay. Yes, yeah, that is a very good person. Okay, you can see like he has eaten for less than $10 and has given the tip of more than $4 to $6. Okay, in between. So he is a very good person, like wholehearted person. Gave good tip. Good. So this is how. So when we plotted the data, so try to analyze this. That when we showed you the graph, like histogram or the what you call the scatter plot, after we show you how to plot it. After plotting, we are discussing the plot. I mean, what happens when total bill increases? Does the tip also increase? Are there any person? What are the outliers? Okay. What is the mean? What is the median? Okay. What is the frequency? Right. We are analyzing those things. So this is known as something known as data interpretation, like also known as data storytelling. Right. You storytell your data. So when you visualize your data, you try to storytell this. So this is known as storytelling. So more than data visualization, what is more important is to storytell your data. So this is what we are doing, this, that is storytelling. That as the bill increases, most bills are clustered around here. And you can see a person who ate less than $10 gave a bill tip of more than like $4 or $5, which is comparatively more even people eating with a larger price, right? And there are also very small chunks of people who gave and spent a huge amount of total bill and also gave a huge tip. Okay, so like that. So this is known as interpreting your plot. Okay, data storytelling. You storytell, and that is what it is more important. And that is one of the major components also. Okay. Okay, fine. Okay, so now we will look into the box plot. Okay, now we'll look into the box plot. So yeah. So this is a box plot. So what is a box plot? It will look like a box. Okay, that is why it is known as a box plot. Okay, and box plots are especially useful when you are plotting a discrete variable against a continuous variable. Okay, So that is when a box plot is really useful. So what is a discrete variable is something which is countable, okay? Like say using whole numbers or something like that. Whereas continuous variable is something like which has a fractional value like 23.6, 23.62, 23.56. You can count forever that decimal places. Okay, so it represents a tiny change every time, a tiny change, and it's therefore a continuous variable. Okay, so that's the idea. And you can see this is the from the tip data set. This is from the tip data set. What I'm trying to analyze here, I'm trying to analyze that who gave the tip given by the, according to the gender, okay, like male and female, right? So you can see on the x-axis it's the sex, like female and the male. So female you can see has given a bit of lower tip as compared to males, okay. I don't know. So you can see male also who has given subsequently higher tip. Okay. So what are each of these lines mean? So this is a box. Till now we know this. This is a box and therefore it is known as a box plot. Okay. But what are these values here? What is this? What is this one? What is this whiskers? What is this? So these all things will be learning now. Okay. So you can see over here like box plots anyway. So you can see here again a different example, men and women and their salaries. Okay, fine. So okay. This slide is more informative than the previous one. So the box plots, the box indicates the range in which the middle 50% of your data lies. I mean, in box plot, you can easily see the summary statistics. I mean, you can easily decode the central tendency measures in the box plot. Okay, how? You can check the mean over here. I mean, the mean is the one with the dotted lines, and the median is denoted with the bold lines here. Okay, the mean and the median, and the bottom side of the box is the Q1, okay, the quartile, and this is the Q3, okay, Q3. The top is the Q3, and in between them is nothing but the interquartile range. In between them is nothing but the interquartile range, IQR, which we understood in previous classes when we were discussing about outliers and skewness, right? And what happens? What happens here? This is the maximum level. This is the maximum level without outliers. And this is the minimum without outliers. However, when any point fall outside of this horizontal two labels, it will be considered as an outlier. If your point falls outside of, these are known as whiskers. These are like whiskers. Okay, like you know the cat. Okay, this is the cat, nose of the cat, and there are whiskers. Okay, so these are the whiskers, okay, of your box plot. So you can see that when a point lies here, it is an outlier, even though when a point lies here, it is also an outlier. Okay, when the point lies outside of these two bars, it will be an outlier. How we decide those bars? I already told in class. It will be how much times the interquartile range? Yes. Okay. So that's good. That's good. So this is why box plot is a bit more famous, or people use it. So, but you have to know each of the subcomponents of the box plot. That is important. Okay. Which is the mean? Which is the median? Which is the interquartile range? Which is the max? Which is the min? And when it goes outside, it will be an outlier. This information you need to know. So this is what is mentioned over here, the first quartile, the third quartile, and in between the Q1 and Q3, it is the interquartile range. And yes, this is the median mean. Yeah. So you can see the T-shaped whiskers go to the last point, which is still within 1.5 times the interquartile range. Okay. So points that are further away are considered as an outlier. Fine. So this is all about the box plot. Okay. Now let us see the, what you call, the box plot here in Seaborn. So you can see again, I'm loading this data set over here. So box plot, I'm creating the figure object. Again, it will be an empty figure object here. I have to add all the details like the data and the axis labels, all the stuff inside. Okay. So fine. So this, I hope you already have known about this LOC. Okay, we are using LOC to again get hold of these tips, like is it a male and a female? Okay, those who are male and those who are female. Okay, you're using LOC for that. So tips, there is a sex column, and in that we are checking. So here again we are creating a Boolean mask. Okay, so this inside this square bracket will nothing but give you a collection of true and false. Just give you a collection of true and false. That's like a dictionary. This Boolean mask and all these things might be learning more in detail in your main Python course. Okay, but for now, just understand the logic behind this. So this you are creating this set of true and false. However, when tips.loc will take the true ones, and you can see here you are checking for the females. Who are the females? So you are collecting the tips from the females. Who are the female? I mean customers at the restaurant, and you are collecting here the male genders from the restaurant. Fine. So male tips and female tips, and what we are doing here, we are creating a box plot. We are creating a box plot. So x is one dot box plot, and what are the inputs we are giving? We are giving the inputs as a list. You can see female tips, comma the male tips. So therefore, the female tips is appearing first as a box and another side box plot. We are creating two different box plots here side by side. One box plot is giving you the female tips on the left and male tips box plot on the right, right? And I am creating a label also for each of the box plot. First label is female and second label is male. Okay, as usual the axis labels and the title of the plot, and plt.show, you can see that how it has given the female and the male limits here, and it has given you the bold line as the median over here. Okay, and these are the whiskers, that is the maximum and the minimum, and this point is considered as an outlier over here. Okay, so there is one female who gave good amount of tip. Okay, I mean the maximum amount of tip given by a female. Okay, the maximum amount. And on the male side, you can see the median is also quite more than the female one. You can compare. Okay, and moreover, you can see that there are a lot of outliers also. There are a lot of outliers also. That means many males, many male genders have given bigger amount of tips or larger amount of tips, money. Okay, so this is the box plot. Okay, so fine. Okay, so maybe what is this is doing? Okay, this will come to different one. Let's go back to our slide. Okay, so now that we know about this univariate and bivariate data, right? We understood about variation of univariate, where you can use histogram, bar plots, and those things. And we also understood about bivariate, where you use line plots, okay, where you use scatter plots, right? Box plots, all those things. So now the question is what you will do if you have multivariate data. If you have multivariate data, how can you analyze? Because you have at least 3 dimension you can analyze, right? I mean x, y, z axis. You can put your data in 3 dimensions at most. But what happens if you have 4 different entries or features, right? If you have 4 different entries, can you visualize it? That's the question. So we can use some aspects of visualization to understand and analyze this multivariate data. Okay, we will see some techniques here. Okay, how to analyze if your data is multivariate. Okay, so this is how it is. You can see multivariate data, like plotting multivariate data is tricky because there is no template that you can use it for every case. Okay, to illustrate how to plot, let's build on our scatter plot. That's what we will see in Python again. So if you want to add to the scatter plot another variable, okay, if you want to add another variable to your scatter plot, suppose, then how can you plot it? So there are two different ideas here mentioned. One option, say sex. Okay, one option is to color the points based on the value of the third variable. Okay, maybe what you can do is color the points based on the male and female. So when you are plotting total bill and tips, suppose you are plotting total bill on x-axis, tips on the y-axis. Now you want to know, you want to add another variable, that is gender. That is the third variable. So how you can add it? Okay. So what you can do, you can color those points. Say male, you can color those points as blue, and female, you can color those points as black. Okay. Like that, you will get two different colors. Like that, you will get two different colors for two different genders. Okay. And indirectly, you are understanding the variation of three different variables, isn't it? You understood? Is it okay? Okay. So now if you want to, suppose you want to add a fourth variable also. If you want to add a fourth variable also, okay, fourth variable. So how you can do? Size of the dots. I mean, if your variable is some variable is bigger, I mean, day you can put bigger dots, night you can put smaller dots. Okay. So indirectly based on the color also, based on the size. So size you added another variable, color you added another variable. So indirectly in the 2D plot itself, you are able to analyze the variation of four different variables, which is quite hard to analyze, right? So, but to be honest, um, if you are using the size as a variable, it has been conceived that humans are not very good at visually differentiating areas. Humans are not very good at differentiating areas. So of course, if there is a bigger dot and there is a smaller dot, you can always analyze. However, if your dot is also like this, how can you compare whether this is big or this is big, right? So humans are not that good. So for that sense, however, if you have big differences, humans are able to distinguish. Okay. Another way, instead of bigger dots, is you can use some transparency. That is the alpha value in your plots. So if you can change your alpha transparency, this is the alpha parameter in your plot. If you change the alpha transparency in your plots, you can make some points darker, some points very transparent. Based on that also, you can analyze your data. Okay. So say take this example for as an instance. What we are doing here is the same plot as before, like we are plotting the total bill versus the tip, but now it is color coded by the sex and also sized by another variable, the fourth variable. Okay. So what is the color? Maybe the blue ones are the males. I don't know in Python what we are following, I forgot. And orange one may be the female. Okay. And there is the size. This is a small size, however, this is a bigger size. This is due to the third variable, that is the sex, and this is due to the fourth variable. The size is the fourth variable. Okay. So indirectly you are capturing the one variable, second variable, third and fourth, four different variables in a single plot. Is it okay? So, but however, try to not do this plot because the sizes are not perceived by humans that clear, as we saw. Okay. Instead of that, what you can do is make some transparent or some opaque. Okay. Maybe some make opaque. Now there are some transparencies. I hope you can see that transparencies here. There is an overlap here. Okay. And you can see that overlap. Now, can you see the overlap here? Okay. So such type of objects you can get by using transparencies from the alpha value, in your plot. Okay. So something known as alpha transparency. Anyway, so this is the idea. Fine. Okay. So anyway, this is Seaborn. We have already used Seaborn. At that time, I could have introduced. But however, matplotlib is the core plotting tool in Python. Okay. And Seaborn builds on the matplotlib. Okay. Seaborn library builds on matplotlib by providing a higher higher level interface to it. And you will get a very nice complex visualization and interactive visualizations. Okay, however, you can use Plotly also. We saw how it can be interactive. It gives us the hover phenomena, like you can hover on the line plots and see different chunks of the data, what they mean. Okay, fine. And you can get a beautiful default styles and also various nice color palettes. And this is the logo of Seaborn. Okay, this is the logo of Seaborn, like where you can see different scatter plot here and the stacked plot, stacked charts. Maybe we can look it into later. Stacked charts, and these are the histograms. Okay, so you can see how the logo is made to make statistical plot even more attractive. Fine. Okay, this is Seaborn. So let us go back to our So this is how it is plotted over here. Okay. Okay. So box plot we saw. Okay, female I am coloring as orange. Okay, this is the hex code. This hash F1A340 is nothing but a hex code. Every color has a hex code. Okay. However, you don't have to be that much complicated. You can just create. I think there is an easier version than this. Okay. I mean, no one will remember these codes. However, there are alternatives. Okay. But remember that you can color also. Every color has a hex code. Every color has a hex code, and using that hex code you can get any color. Okay, so you will have more span of colors also. Fine. So we are creating subplots here. Good. And we are creating a scatter plot here. Okay, data equal to tips. What is the x value of the scatter plot? The total bill. What is the y value of the scatter plot? That is the tip. Okay, and I am changing the tip from based on the size. There is a size column in your tips dataset. There is a size column in your tips dataset, right? What the size column does, you can see I am multiplying it by 2 and 10. Okay, so you can see over here the marker size. It's the marker size. Now based on this size, different points are bigger and smaller. Okay, based on this size. What happened? uh, Something happened. Huh? Internet gone. uh, I have to run again. Okay, let us be back. So you can see I am creating the color and I am mapping. Huh? I am mapping the sex by colors. Okay, how I am mapping? Using the map function over here. Okay, map colors to sex like tips and square bracket sex, like it's taking the sex column of your tips data set. Okay, and then map the colors. And this is the alpha equal to 0.5 is nothing but the transparency I am giving. Okay, to each of the points. And for each of the points in your data set, the transparency is the same. That is 0.5. However, when I meant that don't play with the sizes, rather play with the transparency, this is what I meant, that you don't play with S, rather play with alpha. Okay, play with alpha in such a way that every point has a different value of transparency. So that what does that mean? It means that alpha equal to 0.5, don't keep it constant. Rather keep alpha equal to 0.5 as a variable. Okay, for each point of your data set, make alpha value as a variable. Okay, that means it will, depending on a particular point of your data set, the alpha transparency will change. Okay, maybe some points will be highly opaque, maybe that means something. Maybe some points are very transparent, maybe that means something else. Okay, fine. Okay, so these are the explanations already added. Okay, so therefore you are seeing this plot. Fine. Okay, so okay, we have to run all this again. uh, this we already saw before. Okay, so anyway, we'll take